So let's look at this example. Feel free to pause the video and see if you can try it out by yourself, okay? So this is the second example for the gravitational potential energy grade 10. Alright, so they say a netball player who is 1.7 meters tall holds a 0.5 kilogram netball. Okay, let me fix this mistake here. You must erase this. It's 0.5 meters above your head and shoots for the goal net, which is 2.5 meters above the ground. Okay, so this small information is very important. Okay, what is the gravitational potential energy of the ball? This question is divided into three. The first part is when she is about to shoot it into the net, and then the second part when it gets right into the net and when it lands on the ground. So it usually helps to just like draw a rough sketch in order to like analyze what information is given at what stage. Okay, so I will just try to draw something here. I can't draw, but let's just assume this is the okay, she's holding the ball, right? And then the net is somewhere there, right? And then here's the ground here. So let's just try to analyze this question. So the netball player is 1.7 meters tall, right? So let's just put the information. 1.7 meters tall and holds a 0.5 netball above her head. No? So from her head to where the ball is, it's 0.5 meters, right? And then she shoots for the goal net, which is 2.5 meters. So the net, okay, it's 2.5 meters. That is the total height. So this sketch can already help you to like calculate. Alright, sorry about that. So this rough sketch can help you calculate at each section what information is actually given for you. Alright, my scale, my drawing is not up to scale, so forgive me for that. The ground where she's standing and the ground where the hoop is, it must be the same. So let me just fix that. So I hope you get what I mean. So that's what I mean. So this is the ground, okay? So let's try to calculate when she's about to shoot it into the net. At this point, where is the ball? How high is the ball? Remember, the gravitational potential energy focuses on the height. It's due to the position of the object, right? So when she's about to shoot it into the net, where is the ball currently? Okay, so let's check. Before she shoots, here's the position of the ball. Okay, so what is the total height there? Remember, the girl is already 1.7 meters tall. Then there's another 0.5 meters above her head where the ball is actually at the moment. Okay, so we can try to calculate the total height of the object of the ball. Okay, so answers. So number one, when she's about to shoot, let me first write the information that's given for us. So when she's about to shoot, we have a height of 1.7 meters plus a height of 0.5 meters, which is a total height of 2.2 meters. That's where the ball is currently. So don't just calculate. First think, where am I at this moment, since this information is critical. Okay, and then what else are we given? We're given the mass of the ball, which is 0.5 kilograms, and the gravitational acceleration is 9.8 meters per second squared. As I said, this one is a constant. It will always be 9.8 meters per second squared. So now we can calculate what we are asked. What are we asked to do? We are asked to calculate the gravitational potential energy. So we can write down its formula. Okay, so EP equals to mgh. Our mass is 0.5 kilograms. Our g is 9.8. Our height is 2.2 meters. Then I find that the gravitational potential energy is 10.78 joules. Okay, so that is the answer. Then when it gets right into the net, okay, right into the net, where is the ball at that moment? It's right where the net is. How high is the net? It's 2.5 meters. So it means that number 2, the information that's given for me is that their height right now is gonna be 2.5 meters. Okay, that's where the ball is at this point. Alright, then mass is still the same because we're still talking about the same ball, 0.5 kilograms. Gravitational acceleration is the same, 9.8 meters per second. Alright, then I can calculate what I'm asked to. EP is equals to mgh. So m is 0.5, g is 9.8, height is now 2.5 meters. Then you just put in the calculator, you get 12.25 joules. Okay, now when it lands on the ground, okay, let's check on our little diagram. When it lands on the ground, where is the ball currently? The ball is currently here. Okay, so you can already tell from the previous video that the gravitational potential energy will be 0 because we are now at the bottom. The height is 0. It means the gravitational potential energy is minimum. Okay, so you can just say EP is 0, or you can just try calculate it. Okay, so at the bottom, height is 0, mass is the same, 0.5 kilograms, g is 9.8 meters per second squared. So EP, you can see that I'm writing formulas every time I try to calculate. Don't leave that out, it's actually very important. Okay, I'm not just doing it for fun, it's important. You first write the formula, then you substitute, then write your answer with the correct units. Otherwise you will lose marks in the examination. Okay, everything multiplied by 0, your answer will always be 0 joules. So your answer is 0 joules. Okay, so it actually makes sense from what we discussed in the other video that the gravitational potential energy at the bottom will always be minimum. Okay.